My dear friends, so yesterday I completed all the strain portion I completed, elastic constants were completed, and give the answer questions for the practice. I'm going to write down the answer for yesterday's questions. Question number 5. Is C. Question number 20. When mu is equal to 0.5, Poisson's ratio is what now? 0.5. The volumetric strain will be 0. Question number 29 is Delhi. Next, question number 36. $76.92. In this question, directly what now? Indirectly is given the Young's modulus is given now. Change in stress is given, change in strain is given. Change in stress and change in strain means what a slope is given. Slope is nothing but dy by dx. So indirectly Young's modulus given. And already the shear modulus is given now. Poisson's ratio is given. Then you can find out G. G is equal to E by 2 into 1 plus mu. Next, chapter number 2. Question number 4. Ductile material. Plastic deformation very large when compared to elastic deformation D. Next, question number 6. From tension test, you will get the modulus of elasticity. Yield strength, you will get it. Default tensile strength means the ultimate strength. If nothing is mentioned means tensile strength means ultimate tensile strength. Modulus of rigidity, hardness, modulus of resilience. So you will get it. Shear modulus you will not get from tension test. Hardness you will not get it. Then you can go for the option is what? 1, 2, 3, 6. Question number 7. Bombay. Some students are going for option is C. When should I consider option C? When type of metal is not mentioned. But in this question mention isotropic elastic solid. Isotropic elastic solid means you have to go for the water. It is a metal, you have to take it. But if the simply is given, what is the Poisson's ratio? Which of the limits are the correct for the Poisson's ratio means you have to go for option C. Option C is considered when type of material is not mentioned. B. So in this question, what is given in the question now? Error in what now? G is given, that is dg by G is given now. dg by G. What would be the error in the Poisson's ratio? Then what do you have to do it now? E is equal to 2G into 1 plus mu. That you differentiate and equate it to 0. That you differentiate and equate to 0. From that one you are going to get the dE, you are going to get it, the d mu you are going to get it. Differentiate and equate to 0, you are going to get a d mu. Then percentage of error means du minus mu into 100 percentage. You are going to get minus 0.5. In the question it is given dg by G is given as differentiate and equate it to 0. From this one you are going to get the d mu value now. Then error is equal to then you check it, you are going to get minus 0.5 percentage. E the constant, Young's modulus a constant. So what the constant differentiation now? 0. So differentiate this one and equate to 0. If you differentiate, you are going to get dg by g. So that you substitute it 0.01. Then you are going to get the d mu. Then error is equal to d mu upon mu into 100 percentage. You are getting minus 5 percentage. Next question will be question number 20. What is mentioned in question now? Number of independent elastic constant required to define the stress strain relationship for isotropic elastic solid is 2. Default you are assuming the entire subject is what a solid. I hope you have done all these questions now. So to complete this question, it will not take more time now. So at the end of the class, study the volumetric strain. Volumetric strain is determined by two ways. One method is, if I know the change in volume, then change in volume to initial volume will give the volumetric strain. That is final volume minus initial final volume minus initial volume upon initial volume is going to give the volumetric strain. But the final volume can be calculated only when you know the change in dimensions. Always theoretically we cannot find out the change in dimension. Change in dimensions are known experimentally. So that's why, since final volume is unknown, initial volume is known, final volume is unknown, then we cannot find out directly the volumetric strain. So what the other way can find out now? We can find out the strains in three perpendicular directions. Volumetric strain is equal to algebraic sum of the normal strains in three mutual perpendicular directions. Normal strains in three mutual perpendicular directions. That is epsilon x plus epsilon y plus epsilon z. Now we can find out epsilon x, epsilon y, epsilon z by using E and mu. Epsilon x and epsilon y, epsilon z are known as longitudinal and lateral strains. They are called the longitudinal and lateral strains under uniaxial state of stress. But biaxial and triaxial state of stress, they are called the net strains or total strains. And in case of change in temperature, it is written as thermal strains. Thermal strain in x direction plus thermal strain in y direction plus thermal strain in z direction. longitudinal strain plus 2 times the lateral strain. Under biaxial and triaxial state of stress. In place of the total, we can call the net strain. In presence of delta T, that is change in temperature. Thermal strain in X, Y, Z direction. Therefore, we are going to study this in the thermal stress chapter, but thermal strain in all the 3 directions are same. So it is equal to alpha is the linear coefficient of thermal expansion. Alpha is the linear coefficient of thermal expansion. Delta T change in temperature, because plus or minus, when temperature increase, what happens now? If a body is going to be heated by temperature of T degrees centigrade, all the dimension will increase, length will increase, height will increase, width will increase. Then automatically what now? Final volume is what? More than the initial volume. So volumetric strain is going to be a tensile in nature, or these are all going to be a tensile. When temperature increase, dimension will increase. So these 3 are going to be tensile in nature. When temperature decrease, they're all going to be decreases. Then the compressive. So when should I take a plus now? When should I take the plus means a tensile strain. Minus means compressive strain. When temperature increase, the plus sign. When temperature decrease, the minus sign. Positive means a tensile, negative means a compressive. But how you got this alpha delta T, that you are going to study in the when you are studying the thermal stresses, but you can easily remember now. So when the temperature increases, all the dimension will increase. Length will increase, height will increase, width will increase, the volume will increases. That's why the volumetric strain is positive. Length also increase. Therefore, thermal strain, all the direction is also going to be positive. This is what this dotted one representing now. The dotted one is a deformed shape of the block in presence of the temperature rise. And the red color one is the initial one now. This is possible when the temperature is going to be increases. Temperature increases. So the blue color one is known as about the dotted one is representing the deformed shape of the block because of the increase in temperature. Length will increase, height will increase, and thickness will increase. In this case, how many longitudinal strain, how many lateral strains are going to be there now? X direction dimension is length, Y direction dimension is thickness, Z direction dimension is B. Length will increase, width will increase, thickness increases. So in this case, how many longitudinal strain, how many lateral strains are there? Anybody can give number of longitudinal strain and number of lateral strains. Number of longitudinal and number of lateral strains when temperature is increases. Yesterday I mentioned, but I written because some students was at the end of the lecture is asking, sir, shall I call the longitudinal strain or total strain? Clearly mentioned longitudinal strain, lateral strains are under uniaxial state of stress. In this case, can anybody give the answer is what now? How many longitudinal strain, how many lateral strains are there when temperature is increases? Always Mr. Guptamsh Kumar. Guptamsh Kumar. In Morse circle, always you are going to get the double the angle. In the Morse circle, what now? If any angle, all the planes are represented by double the angle. Why you are getting a doubt now? Sir, the Morse circle, if major principal plane is at 45 degrees from the x face, then is it 45, 20, 22.5? Actual angle is 22.5. Morse circle 2 theta 1 is 45 means theta 1 is 22.5. Satyam Gupta, 1 longitudinal, 2 lateral strain. Shailesh Kumar, 3 longitudinal, 6 lateral strain. Rushikesh, 3 longitudinal strains. Manas, 0. Rito Parsha, 3 longitudinal, 6. Sanjay Gupta, 0. Only 4 friends have given the correct answer. Rajanshu is given excellent now. Sir, since no load is applied, no longitudinal strain, lateral strain, that's absolutely true. Ashish Kumar, 0 longitudinal strain and lateral strains are 6. It is also incorrect now. Sanjeev Gupta, 0 and 0. Answer is 0. Zero and 0. That's why what I have written here now. I have written the longitudinal strain or thermal strain I have written now. Thermal strain. What is the longitudinal strain definition? Longitudinal strain is the normal strain in the direction. Is there any load here now? There is no load. When there is no load, there is no longitudinal strain. When there is no longitudinal strain, there is no lateral strain. What is the lateral strain you have studied now? Lateral strain is the normal strain in a direction perpendicular to the direction of the applied load. Here there is no load is applied. That's why these strains are called the thermal strain. These change in dimensions are due to change in temperature or load now. They are due to change in temperature. There is no load. Since there is no load, load in x direction 0, y direction 0, z direction 0. When there is no load, no longitudinal strain and no lateral strain. That's why you are calling about a thermal strain. Here the dimensions are changed because of the change in temperature. That is only the problem now. Some students are given, sir, 1, 3, sir, this is a 1 and 2. Sir, delta L by L is known as a longitudinal strain, sir. Delta B by B is about a lateral strain, sir. Clearly mention delta L by L is equal to longitudinal strain only under pure axial loading. And delta B by B under clearly written under uniaxial state of stress. 1 longitude, 2 lateral strain. Here stress is 0. There is no load. When there is no load, no stress and no longitudinal strain, no lateral strain. First day itself I clearly mentioned, but still you are using the what now? Hardly only 2 of friends have given the correct answer when I checked it now. Only Rajanshu as well as Sanjeev Gupta has given the correct now. Remaining all are incorrect now. Somebody is 1, sir, 2, 3, sir, 6 are going to be there, sir. Don't simply study the equation. Try to go through the concept now. What is the use now? After studying all the basics now. Mr. Stagg is also given the correct answer. It is not proportional, my dear friend. I mentioned this is what now? Alpha. This is not proportional symbol. This is called as clearly I mentioned. Linear coefficient of thermal expansion. It is not proportional, my dear friend. How can you write down is equal to I written now? Is equal to I written. How the proportional will be there in between now? How 3 proportional to delta T, my dear friend? It is equal to symbol. Then 3. Then how 3 is proportional to delta T? How 3 is proportional to delta T? This is about the linear coefficient of thermal expansion. And clearly I written the reason also. Try to use little bit what now? Common sense now. They're all I written as what now? Alpha delta T. Since these are all equal, what you are going to write on a 3 alpha delta T. Try to use little bit of common sense. Somebody is asking, never so far is asked now. Last my 27 years experience, nobody asked what now. Sorry, the proportional or is it proportional or alpha is nobody asked now. Linear coefficient of thermal deformation. Now next time this also I have to mention in the batches now. Here alpha is not proportional symbol. I have to mention now onwards this also. Don't assume the proportional. Little bit of common sense. I written is equal to 3 I written. How 3 is proportional to delta T? How constant is proportional to delta T, my dear friend? Before asking something now, use little bit of common sense. And next written here also is equal to. They're all equal to alpha into delta T. So these are alpha delta T. Alpha delta T. Alpha delta T. What will get it now? 3 alpha delta T. I clearly written there here below also I written, but you are asking like that now. What should I do it? I don't know now. Mr. Satyendra Kumar. Before sending something on the live chat, use your little bit of common sense. You know everything. If you can strain your brain, then your brain will give the answer now. You know everything. Don't ask directly now. It is written is equal to. How 3 is proportional delta T. If you can answer what directly, you will get the answer now. And you can check this now. You may ask only one question. Sir, how you got it alpha delta T? That already mentioned now. That I am going to derive it in the thermal stress chapter. So many first day itself what now? In your batch, second day itself clearly I written now. Longirus strain are written, lateral strains are written, everything are written now. The problem is what? I will not refer the basics and the definitions. He asked the 100 students, 90 students, what now? 100 students asked what the longirus strain means. Sir, delta L by L, sir, change in length to virginal in the longirus strain. That is absolutely incorrect. Nowhere I written the longirus strain is delta L by L. Refer your notes. Longirus strain is the normal strain in the direction of the load. Lateral strain is the normal strain in a direction perpendicular to the direction of the load. If you can go for that, what now? 3 friends has given the correct answer means they has gone through that now. But you are all remaining, all are giving 1, 3, 6, 3 and 6, 1 and 2. Means you are not focused on the basics now. We want only equations, equation. What is the use of equation without knowing the concept now? When lecture is going on yesterday, one of the friend from UP, सर यूपी में बहुत गर्मी लग रही है सर, हैदराबाद में कैसा सर मौसम कैसा है सर, ठंड है गर्मी है सर बोल के पूछ रहा है. I don't know what he is asked now. If you are getting any doubt, you can enter into the Google now. What the temperature, comparison of temperature in UP and Telangana you can ask now. Is it the what or 2 questions to be asked in the class now? सर यूपी में गर्मी लग रहा है सर, हैदराबाद में कैसा है सर, और दिल्ली में कैसा है सर. This type of question they are asking now. Already explained this definition, but I'm not written the definition on the board now. which are parallel to parallel to shear strain is defined as the change in initial right angle between two line elements which are parallel to x and y axis. This you have studied when you are studying the principal strains you have studied, but there I not written this definition on the board. I've already explained there now. For last almost 20 years from me, I am writing this now. This definition generally is not given in most of the textbooks now. But only 2022 ESC paper this definition is asked in the 4 statements are given. Which of the statements are correct now? In that one of the statement shear strain is defined as the change in initial right angle. Right angle means 90 degrees now. I'm drawing I consider a vertical rectangular block. So far you are taking the horizontal. To explain this one, I consider a vertical rectangular block. Is the front view and top view. Vertical member, you can see the cross section, the top view. When a member is horizontal, we can see the cross section, the side view. But when a member is vertical, we can see the cross section, the top view. This is which axis now? HCA is a VCA, and this will be the polar axis. Is the shape of the cross section rectangular. I consider vertical rectangular block. HCA, and this will be what now? VCA, and Y is about a polar axis. But the polar axis is studied in a perpendicular to cross section. Is a B. So what this line now? Top surface or cross section at the top. This is what now? Bottom surface or cross section at the bottom. And what about this line now? Left side surface. Either right side surface. Either left side surface, right side surface. This line is about now? Top surface, bottom surface. And what about this now? Front surface. Left surface, right surface, top surface, bottom. And this will be about now? Front surface. Now this will be the centroid. Now this axis, which acts on longitudinal axis. What the longitudinal axis? Imaginary line joining the centroids of every cross section. These are centroids, the longitudinal axis. And you have taken polar axis y. Longitudinal axis always coincides with the polar axis. Now this is a HCA. This is what the polar axis. Polar axis perpendicular to cross section. Z is the what now? VCA. Z is the VCA. L. Now this line AB is parallel to which axis of y? And what about this line AD? The line AD is parallel to x-axis. This line AD is parallel to x-axis. This line AB parallel to y-axis. This is also parallel. So what the definition given now? Initial right angle. Actually this is not a line. It is a left side surface. Either bottom surface and this is the right side surface. What the angle between these two? 90. 90. Now whenever you want to get a shear strain, we need a shear force is required now. Shear force is what? Normal load is perpendicular to the surface. Shear force parallel now. So we are going to apply a this is a cross section at the top or top surface. This load is acting parallel to cross section is a shear load, or you call the TSL. If the load is acting along this axis, it is the axial load. What you have studied, transfer shear load is what? A perpendicular longitudinal axis. This load is perpendicular to longitudinal axis. You can call the TSL or shear force. TSL or a shear force or concentrated point load, all are same. Concentrated point load or shear force or TSL. Now, so you have to study after applying this shear force. This is what when P is 0. This diagram is representing initial, that is when P is 0. But if you apply a load like this, what happens now? Length will increase, width and depth are decreases. Now after applying this one, what happens is acting parallel to the surface. It will try to slide this surface towards right side. I'm assuming the B is going to be slide to B dash. B slide to B dash. But this is a fix now. Here is a fix. So A and A dash will remain same. Now this distance you are calling as what? Delta. Delta is not the change in delta is the what now? By how much distance the B is going to be slide now. How much distance? when B is going to be slide by delta, every point on the surface is going to also slide by delta. C is also going to be slide to delta. This is what now? Which phase I can call it? Anybody now? Y. This is going to be what now? Y. So this is a Y phase. Y phase. So this shear stress is called as tau yx. Due to this one, you are going to get a tau. Parallel to which phase now? Y phase. Sorry. This is what a Y phase. And which direction is now? X direction. So the shear stress due to this one is what? A tau yx. Tau yx is going to be there now. This is which phase now? X phase. This is the X axis. This is the X phase. So your cross section is the Y phase. Cross section is the Y phase. So this shear stress is what? A tau yx. And every shear stress associated with a complementary shear will be there now. So when the B is going to be slide by delta, each and every point is also going to be slide by the same amount. Now once again the fixed. Now D and D dash will remain same. Now the shape of this rectangular block is going to be changed. Initially what the AB angle between AB and AD 90. Now this shape is going to be just like a what a rhombus. You are going to get in a rhombus. Shape is going to be gets distorted. So this angle you are called as what? Once again this will be delta. So this angle you are called as a shear angle. Shear angle. So once again what this dimension now? What the initial BC equal to B. What the width of this block B. So initial B, the BC is also B. Now what the find B dash D, C dash. B dash C dash is also B. B. So cross-sectional dimension will remain same. Cross-sectional dimension will change only when normal load is there. That is either axial load or on the cross-section how many loads you have studied? 4 load. Axial load, shear force, bendment and twistment. But here you are getting a shear force. But there is no change in, if you apply a normal load, what axial load, what happens now? Length will increase, width and depth are going to be decreased. Cross-sectional dimension will change. But here you are applying a shear load, the cross-sectional dimension will remain same. So this shear angle, this is called as the shear angle. So what this shear angle is represented now? By how much angle the surface on the left side and right side. Either left surface, right side surface. This phi is representing by how much angle the surface on the left side and right side are going to be gets distorted. By how much angle the surface on the left side and right side are going to be gets distorted. Now what the shear strain definition now? Change in initial right angle. Initial angle is 90. Now what this final angle now? -90 minus 5. One side angle is left side angle is decreased by 5. right side angle is going to be increased by phi. So change in initial right angle is what? A phi. Here actually what the meaning of line element? Line means it is not a line. It is a 2D figure. It is a 2D figure. It is not a line. Actually it is representing left side surface. It is not a line. This is a cross section top surface. The 2D figures now. So this is the left side surface and this is the bottom surface. So one side the angle is what? A decreased by phi. Other side angle is increased by phi. So the shear strain is what this phi is representing now. This you are calling as the shear angle, but what is representing now? By how much angle the surface on the left side and right side are going to be gets distorted. And gamma is about a shear strain. Shear strain. I'm drawing the diagrams are smaller in size because you can what, but in the offline batches I used to draw a bigger one because the board is going to be bigger one. But here you can see on the screen now, your laptop screen, you can check it now. Because since the camera is going to be a fixed position, I cannot occupy this now. So whatever the related entire information of the shear strain, I have to restrict within this space now. That's why I'm drawing the smaller in size. Now if you want to get a shear strain, we need a shear angle. Now to get the shear angle from this triangle ABB dash, from the triangle ABB dash, from the triangle ABB dash, what the tan phi? What the BB dash delta AB is L. But for smaller shear angle, %, simply they will write down the shear angle. But I written what the shear angle is. I not written the board, but I explained the 3 times what the shear angle representing. Shear angle represent by how much angle the surface left side and right side are going to be gets distorted, but they will not write down now. Some students are going to be 10% of the students are going to write down each and every point what I am discussing the class now. But 70% of students are going to be what? Just like a photocopy machines, photostat machines are going to be there now. They will write down only what the teacher is writing on the board. I written phi equal to shear angle, but I not written what the shear angle, but I repeated now. But they will simply write down the shear angle. Afterwards, what the phi means shear angle, but what is representing means we don't know. In the notes is not there, and the textbook is not there. Then shear angle means shear angle, but we cannot tell it what the shear angle now. So try to write down each and every point the teacher is writing now. Then only your notes, the best notes, which is equal to 10 standard textbooks as well as teachers 27-year experience is going to be added now. That is the best notes will be there now. So phi is equal to delta L. Then finally what the shear strain now? Shear strain equal to shear angle, but shear angle equal to delta in delta upon L. Now What is the delta? I'm interested in gamma. To get a gamma, we need phi. To get a phi, we need delta. We know L, initial dimension is known. So if I know delta, we can find out phi. And that phi itself we can call the shear strain. I'm interested in the shear strain. To get a shear strain, I need shear angle. To get a shear angle, I need the delta value. So what is the delta value? Anybody know? What is the delta value? If I know delta, then I know the phi. And if I know the phi, I know the gamma. What is the delta value? I need this value now. What is the delta value? Anybody, what is the delta value now? What is the delta? What is the delta value? Anybody, what the delta value? Sanjeev Gupta, phi into L. Don't give these answers. So delta means L into phi. We want to find out only phi, my dear friend. If you already know phi, why you need the delta value? Everybody is what I'm mentioning what now? Delta equal to L phi. If you already know phi value, then why you need the delta value? My aim is to what? To find out the shear strain. To get a shear strain, I need a shear angle. To get a shear angle, I need a delta value. But if you already know phi, then we don't need the delta value now. Don't tell like this now. Everybody is putting like this now. I'm interested in gamma. To get a gamma, we need a shear angle. To get a shear angle, we need the delta value. If I know the delta, I know the phi. If I know the phi, directly that phi is a gamma. Mr. Abhyuday Sharma is given good now. Displacement of top surface, good, excellent. Displacement of top surface. Or Mr. Bipin Kumar is also given correct now. Distance between B dash due to shear angle, good. Mr. Kumar is given PL by AE. How it is the PL by AE, my dear friend? How it is PL by AE? PL by AE is giving a change in length. Is it a pure axial load now? These are the answers they are going to give it. Now one friend is going to, these are all the common answers I am going to get in every batch now. Everywhere delta is not the change in length here. Is it a change in length now? Is it a, when this formula is valid now, pure axial load? Is it an axial load, my dear friend Mr. Kumar? So these are the answers given by most of the friends. But first time what now? Three friends are given excellent answers. Now, correct now. One friend is clearly mentioned. Delta is the displacement of the top surface. Displacement of the top surface. The displacement or deformation? Displacement. Displacement of the top surface. And somebody is given, sir, BB dash is correct. But what that value? It is the unknown. Delta is the unknown. Delta is representing the displacement of the top surface or distance between B and B dash. This value is the unknown. You have to measure this now. I taken what the B slide to B dash, but whether B slide to here or here or here, we don't know. I taken randomly the what the B dash here now, but actual position is unknown. B may be slide to here or here or here or here, we don't know. So when you don't know the B dash, delta is unknown. How do you know this B dash position now? Experimentally. So if you know the B dash position, then I can measure this distance now. Since the B dash is unknown, delta is unknown. So exact position of B dash is known experimentally. So when experimentally this delta value is known, but we are all studying the theoretically. So theoretically the delta value is unknown. Unknown theoretically. Then how to get it now? I am interested in gamma. To get a gamma, phi is required. To get a phi delta is required. When delta is unknown, what happens now? Phi is unknown. When phi is unknown, gamma is unknown. Then what you that only you have studied what now? Theoretically strain is unknown. Theoretically strain is unknown. Theoretically which one is calculated? Yesterday you have studied elastic constants. What are the elastic constants here written now? Elastic constants are used to determine the strain theoretically. Yesterday I written the elastic constants. The shear angle is determined by what? A shear modulus. Nobody is mentioning that now. Clearly I studied now. Theoretically stress is determined. Strain is determined by what now? Strain is determined by elastic constants. How to determine this phi? By using shear modulus. So actual method is what? First you have to find out that delta, then phi, then gamma. But theoretically delta is unknown. Theoretically delta unknown. When delta is unknown, phi unknown, gamma is unknown. Theoretically which one is known? Shear stress. This is going to be called the direct shear stress. When you have written the stress definition, sigma is equal to limit delta A tends to 0 delta Fn upon delta A. Similarly tau here written as what? Limit delta A tends to 0 delta Fs upon delta A. Then you assume the shear stress uniformly distributed. Then tau is equal to what rate now? F by A. So direct shear stress. So we know the P and we know the area. This is nothing but the top surface only. When I am seeing from the top view, so we can see only this surface now. So what the shape of this rectangle? What the area and B into D? Always which dimensions are given? Length is given, width is given, depth is given, load is known. Then you can find out by using P and B and D. We can find out the direct shear stress P by A. Once you know direct shear stress, then you can find out the gamma by using shear modulus. What the G are written yesterday, tau by gamma. Then you can find out gamma. So once you know gamma, what you can find out now? Once you know gamma, then you know phi. That gamma itself phi. Then delta equal to what? L into phi. So theoretically reverse procedure is going to be done it now. In the starting itself I clearly mentioned, theoretically stress is determined, strain cannot be determined. To determine the strain theoretically we need a elastic constant here. Which elastic constant is required now? Shear modulus is required. So theoretically, what should be the first step? Next, G. Next, shear angle equal to shear strain. Shear angle equal to shear strain. Then so this is a procedure. Even the first day also when I studied about a bar subject to axial load, this only you have done it now. Is the direct shear stress, the shear force upon area. Y phase is not distorted, my dear friend. This phase is not distorted. Somebody is mentioning what now? What the delta mean? They are telling the distortion. This is what remains same. Cross section dimensions are not changed. Width and depth are remain same. This is what now? This surface is distorted. The top surface will remain same. Top surface remain as what? The same rectangle only. Overall shape of the block is distorted because of what now? This left surface is distorted. This is the shape you are going to get it now. This cross section will remain same. This B and this D, that will not change now. That only mentioned for proper understanding. Engineering drawing concepts are required now. This is the actual shape now. This is the centroid. Is a HCA, and this is This is the actual shape of the block. Now this is called a vertical rectangular block. So in the front view, you can put this is a front surface. Already all the basics you have studied. This is a top surface or cross section at the top. This is a cross section at the bottom. This is what the left side surface. This is the right side surface. So this can be seen from the left side, but seeing from the front, this will become as a vertical line. And this can be seen from the right side. Seeing from the front, this will become as a vertical line. Is the front view. So this line is what now? Left side surface. This is the right side surface. Now after applying the what now? This is called as what now? A, B, D. So what this A, B, C, D front surface? This is this is the shape of the block now. This is the final now. So this will remain as rectangle only. There is no change in dimensions here now. This dimension B, this dimension also B. Depth is also same. So overall the shape of the what now? Block is going to be what now? But these dimensions are not same. This dimension is not same. Previously this dimension L. Now this is going to be more than L will be there now. So cross section is not distorted. So what is dimension now? And this dimension also remains same. So the shape of the cross section will remain same. But this is what the change now. This dimension more than L. So overall the shape of the block is going to be what now? Overall shape of the block is going to be gets distorted. And that phi is representing what now? By how much angle What this phi is representing now? This line is the left surface. What this phi is representing? By how much angle the surface on the left side and right side are going to be gets distorted. But if you apply a axial load, what happens now? If you apply a axial load, what happens now? Length will increase. Width and depth are going to be decreased. In that case, the initial area and final area will not be same. If you apply a axial load like this now, in that case, this B dash, this dimension is less than B. It's a B, here also B, because there is no normal load. But if you apply a axial load, what happens now? This dimension not equal to B, less than B. And this dimension also less than D, then cross-sectional area is going to be what? A decrease now. Length will increase and cross-sectional dimension will decrease. That only what? So there is no normal strain here now. There is no normal strain on the surface, on the cross-section now. If you want to get it clear, you can overlap it also. This you can show like this, that also you can show it like it's going to be there now. So this is what before applying the shear force, this after applying now. Using the random terminology, Devesh Verma, sir, amount of distortion of Y face. Somebody called it the distortion length. Pritam Jyoti, distortion length. Initially what? B will be here now. So this is what now? This is about what this line now? What this my hand is representing now? My hand is about a left surface. Now this is going to be distorted like this. So this angle, by how much angle the surface is distorted? Now, this is what a distorted. So by how much angle surface on the left side and right side are going to be gets distorted is given by phi. Phi is the shear angle. But there is no distortion of the top surface now. But here this assumption is what now? The length of this surface and this surface length are same. This surface length and this surface length are same. Left side surface length, right side surface length are same. This is possible by neglecting the bending moment. This shape is possible by neglecting the bending moment. Here how many reactions are possible now? When a shear force like this, at the fixed end, how many reactions you have studied? 3 reactions. So one horizontal reaction towards left side and P into L. This is a moment reaction. So then you are going to get a moment reaction P into L. So here bendment is also going to be there. So this shape is possible. Whatever the shape I shown it now. This is by neglecting the bendiment. This length and this length are equal. Left side length and right side length are equal. That is what now? These two surfaces of the same length. That is possible when neglecting the bendiment effect. So this is not actual shape. This shape is possible. This shape of the block is possible by neglecting the effect of bending moment. So in one of the gate paper, this question was given now. A block is fixed at the bottom end, free at the top end, and subjected to a tangential load at the top surface. Then deformation of the block is due to shear force, bendiment, axial load, both shear force and bendiment, both here to consider. But if it is taken in all the textbook, they have taken simply the shear force. If you ask what now, this distorted shape of the block, the distorted shape of the block is possible, means answer is what, a shear force. But it did ask like this now. A block is subjected to tangential load at the top surface. Deformation of the block is means what now? Both shear force and bending moment. At the fixed end, this is a shear force. So one horizontal reaction towards left side. And P into L, this is a moment. This moment is clockwise direction. P into L. Then moment reaction will be anti-clockwise, will be there now. So because this moment reaction would be subjected to bending is also going to be there now. Then at that time this length and this length will not be same. Whenever you apply what the bending what now, both the lengths are not going to be same. But you have taken this length and this length are same. So this shape is possible. Or this shape now. You can this shape is possible when this length and this length. But if you consider bendiment length, this side length less going to be less than this now. Both will not have the same length now. In this case, this dimension what now? A dash B dash equal to C dash D dash. A dash B dash equal to C dash D dash. This both the surface of the same length is going to be there now. That is possible by neglecting the bendiment. But if you consider bendiment, this length of the surface is less than. This is what now? Less, and this will be more. You are going to get it now. So if somebody will ask now, have you neglected anything in what now? In entire analysis, you are neglected. The bendiment effect is neglected. Bendiment effect is neglected. One force is towards left side now. So horizontal reaction towards left side. P into L. This giving a moment in clockwise direction. Then moment reaction will be anti-clockwise. So this surface is going to be contracted and this surface is going to be elongated because this moment now. That is called, this is called what a bendiment you are going to call it now. What you have studied now. For a vertical member, bendiment is in which plane now? For a vertical member, bendiment is in which plane now? Twisting coupled in horizontal plane. For vertical member, twisting coupled in horizontal plane. So where you can see this cross section, the top view. So twisting coupled in horizontal plane. The remaining two couples are called the bending couples. Remaining two couples are called as what now? This cross section which plane? Horizontal plane. Therefore, for vertical member, twisting couple in horizontal plane. The remaining what now? That is vertical plane couple and profile plane couple is going to be a bending couples. This is what a P into L. So moment is like this. This is in which plane now? Vertical plane. So this is going to be what? Tries to bend the member. Already I studied the bending couple and twisting couple you have studied now. For vertical member, for horizontal member, twisting couple in profile plane. For vertical member, twisting couple in horizontal plane. The remaining two are going to be what? A bending couple. So P into L. while drawing that, this shape or this one now, this you are neglected this now. This in which plane? P into L. P into L is what now? Vertical plane. Clockwise. Therefore, reaction will be vertical plane. This is what now? Bending. Shall I call it a bending couple or bendiment? Both are same. What you have studied now? Bending couple and become as a bendiment at the extreme end. This is the extreme end. So either I can call the bending couple or bendiment. Both are same. We have studied the twisting couple or twistiment. Both are going to be same at the extreme end. The twisting couple at the extreme end will become as the twistiment at torque. The bending couple at the extreme end will become as about the bending moment. So because this one, what happens now? This length is going to be decreased, this length is going to be increased now. But you are not considered this surface length are same, means you are neglected this now. That only I written now. This distorted shape of the block is possible when effect of bendiment is neglected. Why you are neglected the bendiment? Because this length is less. Is a block or a beam? Is a block. Block means what? A length is less. Beam means what now? Length is very large. Suppose this length is very large. So many beam means what now? Beam means what? Cross-sectional dimensions are less. Width and depth are less, but length is so many meters are there now. In that case, bendiment effect is considered. In the beams, bendiment effect is considered, shear force effect is neglected. But this is not a beam, it is a block because length is less. It is called as a block. So difference between beam and a block is what? A beam will be what now? Length is very large and cross-sectional dimensions are very small. Block means length is less now. So in the beams, shear force effect is neglected, only consider bendiment is going to be considered now. But in blocks, shear force effect is considered, bendiment effect is neglected. So in the question is asked what now? It didn't ask all this now. But most of the solution they have given the answer is shear force. Because then all the textbook they will only explain this, that's all. They will write down this one, they are going to leave this portion only. But in the gate examination, very old gate paper is given. A vertical rectangular block fixed at the bottom end and subjected to a tangential load at the top surface, top end. Then deformation of the block is possible. Deformation of the block is due to, first one option is shear force, second one is the bending moment, third one is axial load, last one is shear force and bending. Most of the students has taken only shear force. That is the incorrect now. Both shear force and bending. Only shear force answer is what now? When you have to consider shear force, if clearly mentioned the distorted shape of the block is possible, then at that time only shear force. Now this shape is possible because of the shear force. Should be careful now. If you can see the any of the textbooks, simply they will not write down this now. Simply they will write down what now? This figure they will show it. Then directly write down what now? Tan phi equal to delta by L. Simply phi the shear angle, gamma the shear strain. They will not explain what is the shear angle also. Then simply tan phi equal to delta by L. For smaller angle, tan phi equal to phi, then they will write down, that's all. Only 3 lines will be there. Then everybody is going to write down, answer is shear force. And we're going to cover the delta means PL by AE. So you have to differentiate what you are studying now. You have to differentiate it. What the title you have to put it now? What the title you have to put this now? A vertical block, or simply what the automatically is a vertical only, a rectangular block. A rectangular block fixed at the bottom and subjected to tangential load at the tangential load or shear force at the top. Random words are they are going to use it, random terminology. But if we ask in this question now, where the normal strength 0, normal strength 0 on this now, because there is no change in dimensions. But what about the normal strength in this block? Is non-zero. There is no change in dimension here, therefore normal strength 0, because there is a shear force. But what the normal strength in the block is non-zero. Already explained, this AC diagonal is elongated. Length is increased. This length is what now? Increase. And what about the BD diagonal is contracted? How to find out the elongation of this block, this diagonal now? By using the epsilon n equation. What the epsilon n equation now? 1 by 2 epsilon x plus epsilon y plus r minus a plus 1 by 2 epsilon x minus epsilon y cos 2 theta and gamma xy by 2 sin 2 theta. Similar question here done it now. Gate exam this now. This diagonal is going to be elongated. If it is going to ask, sir, when is the shear force, how you are getting a normal strain, sir? Is the shear force for this surface? It's the shear force for this surface. Is the cross section. But what about this now? Is the oblique plane. AC the oblique plane. For this plane is the inclined load. If you resolve it, you are going to get a two component there. That only I mentioned. You apply any amount, whichever the load, on the cross section, whether you apply a normal load or a shear load. On a cross section, whether you apply a normal load or a shear load. Always an oblique plane, you are going to get both normal and shear. That's why you have studied the sigma and tau equation, epsilon and gamma equation. Is the shear force for this cross section. But this is not a cross section, it is the oblique plane. So for this plane is the inclined load. That's why always on any oblique plane, under any loading condition, whether you apply shear force or apply a bending or a twisting or a axial load on the cross section, always on oblique plane you are going to get the two stresses will be there. But on this one you are getting only shear stress is there, because there is no normal stress. Whenever you want to get a normal stress, your normal load should be there. But for this is what now? It is the inclined load. Then if you are going to resolve it, you are going to get the one shear component, one normal component. Same that only as clearly discussed when a block bar subjected to pure axial loading. For an oblique plane, it is going to be a one normal component, shear component. Therefore, clearly should be careful. What is the normal strain on the cross section? 0. Because there is no normal load. But what the normal strain in the block? Block means you have to consider each and every plane. So this is what an oblique plane. That's why what now? Everybody is going to ask, sir, when a shear force there, how we are getting normal stress and normal strain, sir? This is not a cross section. This is an oblique plane. This AC diagonal is elongated. BD diagonal is contracted. Then how to find out the what? How to find out the change in length of the diagonal, and how to find out the decrease in length of this diagonal. For that only you have to use the epsilon n equation. Epsilon n is equal to, at an angle of theta, equal to 1 by 2 epsilon x plus epsilon y plus 1 by 2 epsilon x minus epsilon y cos 2 theta plus gamma xy by 2 sin 2 theta. this diagonal will be elongated. BC diagonal will elongate. Elongation means what? Length will increase. What about this now? BD diagonal. This diagonal is going to be contracted. This diagonal is going to be contracted. One diagonal elongate, one diagonal is going to be contracted. In one of the engineering service paper also this question is given. It is asked what is the normal strain now, or what is the shear strain this now. Then you have to use that 1 by 2 epsilon x, epsilon n and gamma s equations are required. Clearly mention epsilon and gamma s equations are giving normal strain and shear strain. Normal strain and shear strain on a oblique plane from the x-axis. Elongates, other one is contracts. Here epsilon x and epsilon y will be 0. Epsilon and epsilon y is 0. Only gamma xy will be there now. I have written the generalized equation now. I have written what a generalized. There is no epsilon x. Epsilon and epsilon y 0. Only gamma xy is going to be there now. Then what the epsilon in equation now? 1 by 2 gamma xy. So gamma xy by 2 sine 2 theta should be there now. Who has asked this question now? Pritam Jyoti. Epsilon x, epsilon y are 0, but gamma xy will be there now. Can you show the state of stress here now? Can you show the state of stress for the block now? Now can you show the state of stress? How to show the state of stress? Can you write down the stress tensor here now? By neglecting the bend. That's why I have not shown this momentary action, because this you are neglecting. We are considering only shear force. Now how to show the shear stress now? What the first step you have to do it now? So this will be called as the which phase now? Or top surface, or Y phase. This is right side surface, or X phase. Whatever you mentioned, Swaraj Pandey, because nowadays the students are coming to the classes with the least basics. Out of the 100 students, 30% or 20% students are the concepts are cleared. They know the basics now. But 70% of the students join the what now? These classes without basics. They know only equations. Because this subject, the weightage is going to be more, and based upon this only machine design will be there now. That's why I'm going to spend the more time each and every what now. Initially when I started made it in 2007 now, the subject allotted hours are 80, but I used to take 85 hours only. At the gradually what now the hours are what now recently what it is increased to 100 hours, because including machine design, theories of failure, etc. In offline it will go 130 to 135 hours now. The change in syllabus is what a very less now. Only 2007 and this now. Only 1 or 2 topics are increased. That is the strain rosettes are increased. Other one is what a shear centers. Change in syllabus is what a less. But the students are joining the classes without basics now, because of in most of the colleges. Even already mentioned, some teachers are teaching properly, but some teachers they don't have the proper basics. But students will not bother about the basics now. They want only equation. They will not attend the classes. But one gate examination not like that now. It is not a test for your memory power or equations now, or skill on the calculator. Both are required. First concepts should be cleared. Then if concepts are clear, then you can do the calculations. Accuracy is going to be in your hands now. So that's why what now I'm spending the what more time. Each and everything is going to be explained now. Otherwise simply they know the terminology. They don't know what the only remember saying 5 means shear angle, but what the shear angle they don't know. And if this is not clear when you are going for a torsion chapter now, once again that is not clear now. So we need the shear angle concept. Most of the textbook they will explain the normal strain thoroughly, but shear strain will not be explained thoroughly now. So in this case, can you show the state of stress now? Can you show the state of stress? How to show the state of stress? You have to take a small elemental cube. A small elemental cube should be taken. Can you show the state of stress here now? By neglecting the shear force effect. Sorry, not by neglecting the bendment effect. Always what should be the first step now? To decide the stress now. Show the resisting force. Stress will be always in the direction of the resisting force. First cut it. cut it. Now what this now? Cut surface. If we cut it, what happens? If a member is horizontal, what happens? If you cut it, left side and right side portion will be there. But when you cut it here, what you are getting? A vertical member. One portion will be above, one cut surface above, one cut surface below. This portion is what now? Above, below. A means cut surface above. This is the portion above and this is the below. Now can you show this? Can you show it this too now? Can you isolate it? Now, the same thing you have done when you are studying the stress concept. The portion above. What is this line now? Cut surface above. The shear force. Always what you have studied now, resisting force is similar to the load but opposite direction. It is the towards right side. Always resisting force similar to the load is shear load or normal load. Shear load. Shear load. Then resisting force also be what develop similar to the load but opposite direction. Since acting parallel, here also what the same but opposite direction. So this will be the resisting shear force. Fs is what now? Resisting shear force develop above the cut surface. Above the cut surface. But for equilibrium condition, if this portion should be equilibrium, what happens now? P and F should be equal. Therefore, Fs equal to P. Magnitude was the same. But what the actual term is Fs now? Resisting shear force. Magnitude both are same. But here which one is neglected? Only bendiment is neglected. This P into X is going to be about a bendiment now. That you are neglected here now. Now similarly, can you show the what this line now? Cut surface below. Here, what the reaction now? Reaction is not a load now. Sorry, reaction is not a resisting force. It's a load. This is a reaction, horizontal reaction. Moment reaction here neglected. So your P is towards left side means reaction is going towards right side means reaction is going to be towards left side. Now once again, what about this line now? Cut surface below. What is the red color line? Cut surface above. This is the cut surface below. Same thing you have studied what when a horizontal member is there. Left side cut surface and right side. So here shear force is what which side now? Left side. Then resisting shear force will be now how to check it what now whether these two are correct or incorrect now. This P and P will form about a couple in which plane now? This P and this P. This P and P is forming a couple in which plane now? Vertical plane clockwise. Vertical plane clockwise. What you have studied, always the resisting force are developed similar to the load opposite direction. So this P and this P is forming a couple in a vertical plane clockwise. Automatically these two also should form a couple in the same plane opposite now. Now where you can see this now, this one and this one is what? Form a couple in what? The same plane, opposite direction. So this P and this P is what? Now they are forming a couple in clockwise. So these two will form a couple in same plane, opposite direction. That only clearly mention always the resisting force are developed similar to the load but opposite direction. This P and this P is what are forming a couple in clockwise. These two will form a couple in what now? Anti-clockwise in the same plane. So here what the direction of the stress now? With regard to this surface, what the direction of the stress? Towards left side. Here it is going to be towards right side will be there. Now I am taking about now how to decide how to draw the state of stress. How to draw the state of stress? You take a state of stress represent the stress on the three mutual perpendicular planes. If you know the stress on three mutual remaining, all the planes will be calculated with a oblique plane equation. So what this line now? This line is the which surface now? Which face? X face. This is Z face. This which axis you have taken Z. This is Z face. And what about this now? Y face. This is Y face, X face, and this will be what? A Z face. I am considering a point here now. Considering a point. Always what you have studied, whenever you are taking a state of stress graphical method now, you have to take a small elemental cube. Small elemental cube around this point. Take a small cube here now. Cube. So this face of the cube is represent the X face, Y face, and this is Z face. Now take this cube outside. Take this cube outside. Enlarge it. Then you can show the what are the stress are developed on the three mutual perpendicular plane. So what this cube is represent the three mutual perpendicular plane passing through the point. Sir, which point I have to take it? I am assuming what now? What this stress here at now P by A means we are assuming that every point what the stress is same. So where should I consider this elemental cube? At a critical point. What the critical point? Stress is what now? Calculated point. But how many points are there? Infinite points are there. But at which point you have to do the analysis? Critical point. What the critical point on the cross section? On a cross section, how many loads you have studied? 4 loads. How many stress are there? Now 4 stresses. 2 normal stress, axial stress and bending stress. 2 shear stress, direct shear stress and torsional shear stress. So which point should be considered for stress analysis? Which point should be considered for stress analysis? At which point resultant normal stress, resultant shear stress. 2 normal stress are there, 1 axial and 1 bending. 2 shear stress, 1 direct shear and 1 torsional shear. So at which point resultant normal stress, resultant shear stress is going to be more. At that point you have to consider. At which point resultant normal stress, that the resultant of axial and bending. Next, resultant of direct shear and torsional shear stress maximum. At that point you have to do the stress analysis. There you have to consider elemental cube. But actually in this case now how many loads are there now? Due to this one shear stress and due to bending stress. That bending stress you are not considering now. We are considering only shear effect now. So here you are getting only shear force. Then you are getting only one shear stress. Which shear stress now? Direct shear stress. It is not a twisting moment now. Direct shear stress. And this direct shear stress is written as P by A. P by A means everywhere the stress is same. So at each and every point the stress is same. So you can consider any point for the analysis now. Any point can be considered for the analysis. So always this elemental cube should be considered around a critical point. But the critical point, somebody clear, this is a standard question. We have mentioned the stress is defined at a point. But which point you are going to consider for analysis? We have to consider a point, critical point. But what is the critical point? How to decide it now? Critical point is a point on the cross section. Critical point is a point on the cross section where resultant normal stress, that the resultant of axial and bending, resultant shear stress, that the resultant of direct shear stress and torsional shear stress is maximum. So stress analysis should be considered at a critical point on the cross section. Critical point is a point where resultant normal stress, resultant shear stress maximum. But in our case, we are getting only shear stress and bending stress, but bending moment is neglected. Then you have to consider only shear force. So when shear force there, we are assuming the what now? Shear stress uniformly distributed. So you can consider any point. Now take this cube. This cube is this face of this cube is in the right side face, top face, that is the X face, the Y face, Z face. Now take this cube outside. Now draw this cube outside and enlarge it. Is a Y, Z, X face. Now you can see now, this is a cut surface. Now this cut surface coincide with which face of the cube? This cut surface will coincide with the which face of the cube? Is a right side face, top face, left side face, bottom face, front face and the back side. This cut surface is coincide with which face of the cube? This point is what, this will coincide with the bottom face. This line, this surface will coincide with which face now? Bottom face. That is which face now? Y face. Now, so due to this one, you are going to get a shear stress. Is it tau yx or tau xy? It is going to be tau y. Is a which face now? Y face. Which axis now? Y. So Y face and which direction? X. Tau yx. What this represent the bottom surface, bottom face of the cube. That is coincide with the cut surface here now. Tau yx. Then for equilibrium, already you have studied about now. Complementary shear stress are equal, unlike you have proved it now. Tau yx. Due to this one, you are getting about now. This stress multiplied by area. This stress multiplied by area, you are going to get a force in which direction? X direction. So if the sum of the force X direction should be 0, due to this one you are getting a force towards left side. So if the sum of the force X direction should be 0, we need a now because this one what happens now? Sum of the force are X direction 0. Now these two will form a couple in which plane now? Vertical plane in clockwise direction. Vertical plane in the clockwise now. Now, for equilibrium, sum of the couple should be 0. Mean what now? These two are forming a couple in vertical plane clockwise. So if the sum of the couple should be 0. Now these two will be what now? Forming a couple in vertical plane means about which axis now? Z axis. 1 force I already shown it. This force is F1. This force is F1. Both are equal. two equal parallel opposite forces will form a couple. These two forces can be seen in the front view. That is what now? Vertical plane. Vertical plane which acts perpendicular z. Therefore, this is CZ. So if this couple is what? A clockwise. If the sum of the couple about z axis should be 0, we need an anti-clockwise couple. Then you are getting this is tau xy. This is a tau xy. Now due to this one you are getting a one force F2. In which direction? Y direction. Now if the sum of the force y direction should be 0. Now sum of the force are 0, sum of the moments, sum of the force are 0. X direction 0, y direction 0. But if the sum of the couple, now these two will form a couple in what now? Vertical plane anti-clockwise. These two will form a couple in vertical plane clockwise. So by equating the sum of the couple to 0, what you got it now? Tau xy equal tau yx, you got it now. We already proved it. By you equating the sum of the couple, this couple is C1 clockwise. This couple is what? Anti-clockwise. So C1 plus C2 equal to 0, you got the tau xy equal tau yx. Sorry, this is tau xy. Now how we have shown this figure now? In 2D figure, how we have shown this now? Now if the biaxial or triaxial state of biaxial stress are developed only in two perpendicular x and y direction. So biaxial state of stress represented by square. So this is a state of stress for this given loading condition. But this is possible by neglecting the Bendiment effect. Bendiment effect is neglected in the blocks now. How we got these two are equal and unlike now? By equating the sum of the couple that already approved it now. Now can you write down the stress tensor? If you know stress tensor, then you can write down the strain tensor. So what the stress tensor you can write down for this now? The stress tensor. This only called about a pure shear state of stress. Sigma x plus sigma y 0. Now these two planes are what? A principal plane. These two are the what now? Principal plane. These are the various studies. This example when you are studying the pure shear state of stress, that is what now? Pure torsion example. Pure torsion now. So this pure torsion example, sigma x 0, sigma y 0, tau x y equal tau. So the same state of stress also possible when a rectangular block subjected to shear force and neglecting the Bendiment effect. Sigma x equal to 0, sigma y is equal to 0, tau x y equal to tau. The same state of stress possible when now? When shaft is under pure torsion as well as what now? A block subjected to shear force and neglecting the Bendiment effect. Now can you write down the strain tensor? How to write down the strain tensor now? If you know stress tensor, how to write down the strain tensor now? If you know the stress tensor, then you can write down the strain tensor. 0, 0, this should be replaced by gamma by 2. Should be replaced by gamma by 2. But this should be what? A minus or plus now? This is what a tau xy. Tau xy is negative or positive? Negative. Therefore, I taken minus. Stress tensor should be a symmetric. Now you can do the strain analysis. How to do the strain analysis now? Now can you write down the epsilon in equation? How to write down? You want to find out the, this diagonal is going to be what now? Increase now. How to find out the change in diagonal you have studied now? What the strain tensor you write down now? If you know stress tensor, you can write down the strain tensor. What the modification? Sigma should be replaced by epsilon and tau by gamma by 2. So what the strain tensor I write down is 0, 0, and this is what now? Minus gamma by 2 and minus gamma by 2. Now you can write down what somebody was asking now. Which one is 0? Strain tensor. Sigma x 0, sigma y 0 means epsilon x 0, epsilon y 0. Only which one will be there now? Gamma xy by 2. Then you can write down the epsilon in equation. What the epsilon in equation for this now? Epsilon in equation. Gamma xy by 2 sine 2 theta. What the epsilon in equation? 1 by 2 epsilon x plus epsilon y. Epsilon x 0, epsilon y 0. This is sigma x. Now you can write down the strain tensor. Then you can do the analysis now. Sigma should be replaced by epsilon and tau should be, sigma should be replaced by epsilon and tau should be replaced by gamma by 2. So if you ask what the increase in length of this diagonal, how to find out the increase in length of this diagonal now? By using epsilon in equation. 1 by 2 epsilon x plus epsilon y. But epsilon x epsilon y is 0. 1 by 2 epsilon x minus epsilon y cos 2 theta. That is also 0. And tau gamma xy by 2. Gamma xy by 2 sine 2 theta. This is called what a pure shear state of stress. These two diagonals are what now? Principal planes. And these two diagonals are the planes of pure shear stress or tau max plane. This is all you have studied now. So remaining thing you can write down. Already I completed the principal strain chapter you have studied now. That's why I completed that chapter now. Now once you know this one, then you can complete the strain tensor. 0. Strain tensor what? 0, 0, and it should be gamma by 2. Mean which one is 0? Epsilon x 0, epsilon y 0, gamma xy by 2. Gamma xy by 2 is non-zero. Then you can write down the epsilon n as well as what now? Gamma s equation. Now you can substitute the theta value. Then you can find out the normal strain and shear strain on any oblique plane. So the remaining portion I am not doing because already I completed the, I written the stress tensor. Clearly what you mentioned now, strain analysis is similar to stress analysis. Strain analysis is similar to stress analysis, only the 3 modifications you have studied. First one is what now? In stress analysis, theta should be measured from x phase in clockwise direction, but strain analysis from x axis in anti-clockwise. And what the other change? Now, sigma should be replaced by epsilon, tau should be replaced by gamma by 2. And what the third change you have studied now? In Mohr circle for stress analysis, radius will represent the in-plane tau max, but strain analysis, radius will, diameter will represent the in-plane gamma max. Diameter will represent the in-plane gamma max. Once I am mentioning if anybody is neglected while drawing this state of stress, what the answer now? Sir, we have neglected the bendiment effect, that you have to mention it now. Only one new point I mention, where you have to consider this elemental cube. Where you have to consider this elemental cube at a critical point. Critical point is a point on the cross section. Critical point is a point on the cross section where resultant normal stress and resultant shear stress. What the resultant normal stress means? Resultant of axial and bending stress. Resultant shear stress means resultant of direct shear and torsional shear stress is going to be maximum. So if somebody will ask now, when you are going to get a pure shear state of stress? One example you have studied so far, what? A pure torsion. What the other example mean? What? A block subjected to shear force and neglecting the bending effect. A block subject, you need not mention, always default in the blocks bending effect is neglected, only shear force. In the beams, when you are writing the chapter number 4, deflection of the beam, all the deflection of the beam methods now, double integration method, moment error method, Macaulay's method, there you are neglecting the shear force effect now. The principal plane. So on this plane, which strain is 0? No, shear strain 0. If you ask what the shear strain along this, no, 0. Principal plane, shear stress 0 means shear strain 0. Sometimes they will ask what is the shear strain along this diagonal, 0. Because they are principal planes. Principal plane, normal strain will be there. Shear strain is going to be 0. On these two diagonals, we are going to get only normal stress, means normal strain will be there. Shear stress 0 means shear strain 0. I am giving the basics concepts. By using these concepts, you have to complete it now. For that one, you have to vote now where the resultant normal stress maximum, where the resultant shear stress maximum. We should know the bending stress variation and torsional shear stress variation. So far you have studied only axial loading. Sigma equal to P by A and direct shear stress equal to P by A. We have studied only axial stress variation. You have studied axial stress variation, rectangle you have shown it now. But the bending stress variation and torsional shear stress variation we are not studied. That is going to be studied in the chapter number 5 and chapter number 6. Critical point is a point where resultant of axial and bending stress, resultant of direct shear and torsional shear stress is maximum. But so far you have completed only axial stress variation and completed. The bending stress variation where the bending stress maximum and torsional shear stress maximum, that you are not yet studied, that will be studied in the chapter number 5 and chapter number 6. Once again, whatever I am writing, this is not as per the syllabus. Only some of the examination, engineering service examination. This will be studied generally in the, once again, advanced mechanics of solids, or generally in machine. Those you are going to the machine design, MTech, design, what now? There you are going to study it now. But some of the engineering service paper 2 or 3 times this question is asked now. Some of the batches are left it, but most of the students are forwarding after completion of the subject now. When I given my contact number, sir, we are able to do each and every, but this question you are unable to do it now. So some batches this also going to be discussed in a differential form of the strain. And once again, don't ask me how we got the equation. We are not discussing this only for extra information. It is not as per the syllabus now. Only some of the engineering service examinations I mentioned, objective prelims paper, they are deviating. That's why I mentioned in principal stress chapter 2-3 questions are pending. For that one, you need the torsional shear stress, variation, bending stress. That questions can be completed after studying the axial bending and torsional shear stress. So let U is a deformation vector. U is a deformation vector. Then what the Ux, Uy, Uz? Ux, Uy, Uz are the scalar components of deformation vector along x, y, z. They're all the scalar components of deformation vector. What the IZK unit vectors? Suppose the force vector, how to write in the force vector? Fxi, Fij and Fzk. Same thing what now? Ux, Uy, Uz are the scalar components of the deformation vector along x, y and z axis. But for my convenience, I am assuming Ux is going to be U. Uy I am considering as V. Uz you are considering as a W. So W. So now what the UVW? UVW are the scalar components. UVW are the scalar components of the deformation vector along x, y and z axis. Now how many independent components are the strain tensor? 6. What are they? Epsilon x, epsilon y, epsilon z, gamma xy, gamma xz, gamma yz. So if I know that sometimes this vector will be given. If you know this vector, directly how to get the epsilon x? Partial differentiation dou u by dou x. Partial differentiation of the, I need a normal strain along which axis? X axis. So if you want to get a normal strain along x axis, what do you have to do it now? You have to partial differentiate the scalar component of that vector along x axis, that is the ux. But that ux I am calling as a u for my convenience now. So the normal strain along x axis given by partial differentiation of the scalar component along x axis with respect to corresponding coordinate now. So same thing what about the epsilon y? Y direction but the scalar component uy that I am writing as v. And that has to be differentiated with respect to corresponding coordinate is the y direction y. Uz equal to partial differentiation of the corresponding scalar component uz that I am writing as a w with respect to corresponding coordinate z. But similarly shear strain. When you are doing the normal strain, what you are doing now? Thus corresponding scalar component here differentiated what now with the same coordinate. But here you have to do the reverse now. So this is written as what now? X direction what the scalar component u. But this should be differentiated with respect to y. Here only what, sir, why you are doing like this now? So we don't have all this thing, try to remember that's all now. Then y direction what the scalar component v, and but that should be differentiated with respect to x. X direction what the scalar component u, but that should be differentiated with respect to z, and z direction what the scalar component w. Y direction what the scalar component v, and z direction is w. So only two times this vector is given and asked to determine the gamma xy. But you want to write down the total strain tensor. If this is given now, then you can write down the strain tensor. That is going to be possible for conventional papers now. But in objective examination, they may ask any one of this thing now. So I'm leaving this question. This you can complete it now. Determine strain tensor. Now this you can complete it now. So this, what the u value now? Ux equal to u. Now do it and substitute the x, y, z values are given. That point is about now the triaxial x, y, x coordinate is given, y coordinate is given, z coordinate is there. So do the partial differentiation in terms of, then finally can replace the x, y, z by what? X is equal to 50 and y is equal to 40 and z is equal to 20. Then write down the strain tensor. How to write down the strain tensor? When you are writing the strain tensor, this should be gamma xy by 2. You have to consider gamma xz by 2, gamma yz by 2. This you can complete it now. For example, what the epsilon x? What this value now? What the differentiation of this now? 40x. But what the x coordinate? X coordinate is 50. So this will be 40 into 50, 2000. So like this you can complete the remaining now. Then write down a strain tensor. But in the strain tensor you take the gamma xy by 2. But in objective examination they are asking only one now. Any of this, generally they will ask this only, they are going to ask now. The next, how to get the gamma xy? Differentiate this now. Differentiate this with respect to y, and this should be differentiated with respect to x. This should be differentiation, partial differentiation with respect to y, and this should be differentiated with respect to x. Then write down the strain tensor. I have taken the values randomly. Check it. One of your friend is given the matrix like this. I hope you are taken by 2. Mr. Anurag, I hope you are taken by 2. Is it okay? This is okay now. Check it now. Okay. Good. Okay, good. Now once you know this one, then you can do the calculations. You can do it now. Epsilon x, epsilon y and epsilon z. This is gamma xy by 2, gamma xz by 2. This is a gamma yz by 2. So most of them got the correct answer. Now you can come to the next topic now. Expression for volumetric strain under triaxial loading. So to consider this one, I consider a rectangular block with the dimensions of length, width and thickness. This pulled water towards left and right. X direction is pulled with a force of Px. Pulled top and bottom, front and back. Now, what is the expression for the volumetric strain? So to get this volumetric strain, shall I use the first equation or second equation? This is valid under any state of stress condition, maybe uniaxial, maybe biaxial, maybe triaxial or hydrostatic also. But this is valid only hydrostatic. Now it is a hydrostatic or non-hydrostatic. It is a triaxial only. But the hydrostatic or non-hydrostatic, everybody is going to tell, sir, it is a non-hydrostatic. We cannot tell it now. Sir, how it is a hydrostatic? Hydrostatic means what? A sigma x, sigma y, sigma z should be same. But here loads are given. Px, py, pz. But stress are equal or unequal, we don't know. Only after calculation. After calculation, by chance sigma x, sigma y, sigma z are equal. Then the hydrostatic. So without knowing the numericals, we cannot tell it now. This may become either hydrostatic or non-hydrostatic. So better to use which equation of this now. But this can also be valid in this case. But everybody is going to tell, Sir, equation 1 is not valid. Sir, is a non-hydrostatic. We cannot tell it now. Hydrostatic means sigma x, sigma y, sigma z should be equal and like. They're already like in nature. They're all tensile, but the magnitudes are unknown. If the numericals are given in such a way that is, if px, py, pz, length, width and thickness are given in such a way that what now? If the sigma x, sigma y, sigma z are equal, then it is a hydrostatic now. Under hydrostatic state of stress, this is valid under any if it is going to tell the equation 2. Sir, equation 1 is not valid. May also valid. But without knowing the numericals, we cannot tell it now. Without knowing the numericals, we cannot decide it. So better to use which equation? This equation should be used it now. All are tensile only. All are tensile. By chance, they are all equal magnitude. Then it is a hydrostatic. But without knowing the numericals, we cannot tell it now. So, by chance, this is given as a compressive load. By chance, this is given a compressive load. Then at that time, directly you can tell it what now? Is a non-hydrostatic. Because two are tensile, one is a compressive. But here all are tensile only, mean they are like in nature. But the magnitude is unknown. Now this much amount of stress, where it is developed now? This much amount of stress is developed what now? On X phase. This is the X phase. This is the Y phase, Z phase. This much amount of stress developed on the X phase. But stress is defined at a point or at a phase? At a point. But X phase means what now? At every point. When this P by A equation valid now? When P by A equation is valid, when stress are uniformly distributed, means if you take any point on the X phase, if you take any point on the X phase, the value of the stress is this much now. At each and every point on the X phase, this sigma x will be there now. And this much amount of stress where is developed, everybody is going to tell Y phase. But stress is defined at a point. But you are mentioning Y phase, means what the answer now? If you take any point on the Y phase, the stress is same. Then only you are using the P by A. Suppose this is X megapascal, this is the Y and this is Z. So X megapascal is what? If you take any point on X phase, the stress is X megapascal. If you take any point on the Y phase, stress is Y megapascal. And if the Z megapascal means any point on the Z phase. So which point should be considered for state of stress? Which point should be considered for state of stress? State of stress should be considered where? No, critical point. Means at all the points stress is same. Here also all the points stress is same. On this also same. So which point I have to consider? On X phase, which one the critical point? Any point. Every point is the critical point. Y phase also which point is the critical? Every point is the critical. Z phase also every point is the same. Stress is same now. So you can take any point now. Now if I consider a point here now. So this point belongs to how many faces now? X, Y and Z. So when this point is on X face, how much stress is there now? Sigma X. When this point is on Y face, how much stress will be there now? Sigma Y. And when this point is on Z face, this is what now? Sigma X. This is sigma Y. This is sigma Z. So any point you can consider it now, because stress at every point is same. So now after considering the point, what do you have to take it now? We have to consider a small elemental cube. So what the face of this cube is represented now? Z face. That is the no. This is representing X face. Now take this cube outside and enlarge it. Now take that cube outside and enlarge it. So what this cube is representing 3 mutual perpendicular points passing through a point. Which point means what? Any point on the cube, because stress at every point is same. Is a triaxial. By chance they are all equal, then the hydrostatic state of stress. And what the matrix representation now? Now if these are all equal, then it is a hydrostatic. But are they equal or unequal? We don't know, because numericals are unknown. So you have to use this equation. Now what if I know epsilon x, epsilon y, epsilon z. If I know epsilon x, epsilon y, epsilon z, then you can get the volumetric strain. What the epsilon x? We are going for the equation. This is better now. It's valid under any case of any state of stress. So I have to get the epsilon x, epsilon y, epsilon z. Now if I ask that this expression for epsilon x, epsilon y, epsilon z, two friends are going to give this. I'm writing the, if I ask them in the offline classes now, what the expression for epsilon x, epsilon y, epsilon z, 30% of students are going to give this answer, whatever I'm writing now. So these are the answers given by 30% of the students in a batch of 300 to 400 students now. Here, and around 20% of the students, they will give this answer now. So these are the answers given by second vote, 20% of the students. These are the answers given by expression for epsilon x, epsilon y. Almost 30 to 40%. This is what around 20% now. Now whose answers are correct now? Whether these expressions are correct or these are correct now? Anybody now? Some friends are going to give these are the expressions. Some friends are going to give these are expressions. Which one is the correct now? First one is the incorrect. This is valid under the Longius strain. Young's modulus will give always Longius strain. Mu means lateral strain. This Longius strain multiplied by Poisson's ratio will give the lateral strain. So this will be a Longius strain. This is a lateral strain, lateral strain. So this is valid only under uniaxial state of stress. So these answers whoever is given now, these are correct when sigma y and sigma z 0. These two are what? These answers are correct when sigma y, sigma z 0. That is uniaxial case. But here sigma y and sigma z are non-zero. Therefore answers given by these friends are what? It is the incorrect now. Uniaxial state of stress. So for this given question, these answers are incorrect. Now for this given question, they are incorrect. And what about the other friend that has given this answer now? Is it correct or incorrect now? Everybody is going to tell incorrect. It is valid under uniaxial or biaxial or triaxial? Triaxial. But everybody is going to tell, sir, it is incorrect. It is a correct. Anybody can tell what now? When this expression B are correct now? When these expressions B are correct? B is correct. Mr. Lokesh Sinha is given B is correct. Rajanshu. Sir, both are wrong. We have to use superposition principle. Vicky Upadhyay. Both are incorrect for triangle. Most of them have given both are incorrect. Supreet Kumar is given B is correct. Somebody has taken resultant should be taken. What Mr. Swaraj Pandey got a doubt in the expression ux, you also wrote z term. That I changed it. Mr. Swaraj Pandey, I changed that z. Z I changed to constant. Check it now. Check it. Initially I written as a z, but afterwards I changed it. I hope you got the correction now. Mr. Swaraj Pandey, in the previous matrix, that deformation vector ux initially as written as z, but afterwards that z I changed it to constant. Probably that you are not noticed. I hope you got it now. B is correct, Mr. Shantanu. B is correct when poisons ratio 0. Good. Manas is also correct. Now you got the answers now. So 2 friends have given the correct now. B is also correct. Mr. Shantanu is given correct. Good. And Manas is also given correct. Ram Kumar is also correct. So this B is correct under triaxial only. But he has considered longitudinal strain, longitudinal strain, longitudinal strain, longitudinal strain. Means he has not considered in each direction how many strain he has taken now. 1 longitudinal, 2 lateral strain. But this he has considered only longitudinal strain. Lateral strain he has not considered. Why you are not considered means, sir, I assume the Poisson's ratio 0. So second friend also answers are correct now. This friend answers are correct. They are correct for, but everybody is mentioned is incorrect now. It's correct under cork example. Sir, in the question nothing is mentioned. I assume the cork now. So these are all what longitudinal strain in x direction, longitudinal strain in y direction, longitudinal strain in he has neglected the lateral strength is neglected because of Poisson's ratio 0. But when you are deriving now, when type of material is not mentioned, then you have to write down in terms of mu. So when you are deriving, always we have to derive in such a way that it is valid for any material. But whatever the second friend is what now, why you are considered means they have mentioned, sir, I have assumed the Poisson's ratio 0. But always you have to derive for a generalized case. Generalized case means that equation valid for any material. Equation valid for any material. Okay, no problem, Mr. My dear friend. Nothing. What now? You can continue what now? Though they are written the strain tensor initially are written that, then you can continue with that same now. But afterwards I modified it. Okay. So additionally what I have to consider now? Additionally you have to consider lateral strain should be considered. They're all why I am writing now. Because we are all going in the, so many times I mentioned successful persons are going to learn the mistakes committed by the failure category. So these are the possible what now answer they are going to do it. Now some of the friends they are going to give like this now. Now to get the epsilon x now. Here which elastic constant I had to use it now? Neither Young's modulus is valid. When Young's modulus and Poisson's ratio valid now, uniaxial, that only yesterday now. You have to do the superposition principle. Superposition principle. First assume the px alone, py alone, pz alone, that only you have to do it now. So now I am preparing a tabular form here now. superposition principle, that is assume the each load alone. Why now? Young's modulus valid under uniaxial, but this is a triaxial. So we are assuming the first px alone, py alone, pz alone. Now I am preparing a tabular form. Horizontally I am taking the strain, vertically I am taking the load. First I am assuming the px acting alone. Now I am drawing the 2D figures now. I am drawing the 2D figure. I am drawing the front view. Always on the board we can see what a front view. Board is a vertical plane. So we can see this now. Now this will be which line now? X face, this is Y face and the Z face. Px applied on which face now? X face. Now this will become about a pure axial loading now. Uniaxial state of stress. So this is the X face, Y and Z face. It is about a pure axial loading. Now can you complete it now? X direction, what you are going to get? A longitudinal strain. What is the longitudinal strain? Strain in the direction of the load is an X direction. So X direction you are going to get a longitudinal strain. How to get a longitudinal strain now? How to get a longitudinal strain? Stress in the direction upon Young's modulus. What is the stress due to Px sigma x upon Young's modulus? Then Y and Z direction, what do you get? The lateral. What is the lateral strain? A strain in a direction perpendicular to the direction of the load. So which directions are perpendicular direction of the load now? That is Y and Z. Y and Z you are going to get a lateral strain. How to write down the lateral strain? So this is representing longitudinal strain in X direction, longitudinal strain, lateral strain in Y direction, lateral strain in Y Z direction. So this row is valid what when Px acting alone. Same thing, assume the what now? Py the acting alone. Py is applied on which face? Now Y is applied on Y face. Now this line is the Y face. So once again it is a uniaxial state of stress. Now load in Y direction. Y direction will get a longitudinal strain. X and Z will get a lateral strain. So how to get a longitudinal strain? Stress in the direction, that is sigma y upon E is the longitudinal strain, and lateral strains are in X and Z direction. How to get a X lateral strain now? Minus of mu multiply by longitudinal strain in the direction. Next. Then Pz is acting alone. PZ is applied on Z face, that is the front face. PZ is applied on front face. Now Z direction, you are getting a longirus strain. Longirus strain is the normal strain in the direction of the load. Load is in Z direction, means Z direction longirus strain. Longirus strain given by stress upon Young's modulus. Lateral strains are X and Y. That's why what do you mention? E and mu are valid under uniaxial state of stress. So this row is valid when Px acting alone. This row Py acting alone, Pz acting alone. But here all are acting simultaneously. All are acting simultaneously. So how many strains are there now? X direction. One longirus strain, two lateral strain. So what the total strain in X direction? Longirus strain plus two lateral strain. If we add all this thing, you are going to get a total strain in X direction. Now if you add all this thing, you are going to get a total strain in Y direction, total strain in Z direction. So what this is representing now? What the matrix of this table is representing now? Sorry, not matrix. What the diagonal of this is representing now? What the diagonal elements are representing? They're all representing the longirus strain, longirus strains. Longirus strain is the longirus strain X, longirus strain in Y direction, longirus strain Z direction. So the remaining non-diagonal elements are representing the lateral strain. Non-diagonal elements are representing the lateral strain. So these are all lateral strains. Lateral strains. Now, if I add all this thing, if I add the strains in the second column, if I add the strain in the second column, then you are going to get the total strain. If I add all this thing, total strain, the longirus strain, two lateral strain. So what the total strain in X direction? Sigma X by E minus mu sigma Y by E minus mu sigma Z by E. If I take the E as a common, 1 by E as a common, then you are getting sigma X minus mu sigma Y plus sigma Z. Epsilon X means total strain or net strain, anyone. If I add all this thing, by adding the strain in the second columns, this will give the what the normal strain definition is written yesterday. No, normal strain any direction is given by change in dimension in the direction upon virginal dimension. X direction, which dimension? Then L. So from this one we can find out the delta L. You know already sigma X, you know sigma Y, you know sigma Z, and you know E and mu. Then you can find out that delta L can be calculated. So you can easily remember this now. Epsilon X equal to 1 by E sigma X. Remaining two stress are in the within the bracket. Similarly, what the epsilon Y? y direction, which dimension there? No, delta t. So what the use of the equation now? We can find out the total strain. We can find out the total strain in three mutual perpendicular directions, as well as you can find out change in width, change in thickness. Sorry, you made a mistake. In any loading condition, is it valid for triaxial or biaxial or hydrostatic or non? Any case, uniaxial means which one you have to make it sigma y and sigma z 0. When bar subjected to pure axial loading, only sigma x is there. So these equations are valid for any state of stress. For uniaxial, sigma y and sigma z 0. For biaxial, which one is 0? Sigma z 0. For hydrostatic, what I have to make it now? Sigma x, sigma y, sigma z are equal. So what the advantage of the equations now? This equation 3, they are used to determine the normal strain in three mutual perpendicular direction and change in dimension under any state of stress condition, maybe uniaxial, maybe biaxial, maybe triaxial, or maybe hydrostatic. For uniaxial, you have to make sigma y and sigma z 0. Biaxial, sigma z 0. Hydrostatic means sigma x, sigma y, sigma z are going to be equal. Now I'm going for a generalization here. Suppose change in temperature is also there. This concept, whatever I am studying now, this is required in case of when you are going for the thermal stress chapter. Loads are there and temperature is also increases. Temperature is also increase. Loads are applied as well as what now? This concept is once again when you are going for the thermal stress required now. So when temperature also increase, what happens now? Due to change in, once again, what the next column you have to do it now? Due to delta T. Delta T. Due to change in temperature, what happens now? When change in temperature alone, then you are going to get a thermal strain. Thermal strain in x direction, thermal strain in y direction, thermal strain in z direction. That all you are written as what? Alpha delta T. Alpha delta T. Now what the total strain? They're all what a normal strain. All are normal strain. It is also normal strain, normal strain, normal strain. It is also normal strain. So you have to add the what now? Plus if change in temperature is 0, if change in temperature 0, this is 0. So what the use of this now? This valid what now? Suppose only change in temperature is there. If only change in temperature is there, Px0, Py0, Pz, now these are all 0. Then you are getting only alpha delta T, alpha delta T, alpha delta. So these are the generalized equation. They are valid under any state of stress as well as change in temperature. If only change in temperature there means what now? Sigma x, sigma y, sigma z are 0. If change in temperature 0, then at that time alpha delta T 0. If both are there, then you have to consider for total how many strains are in x direction now. In x direction, how many strains are there? Due to this one, you are getting a one longitudinal strain. X direction due to Px, one longitudinal strain. Due to Py in x direction, lateral strain. And due to Pz, z direction, once again x direction, longitudinal strain. And due to change in temperature, one thermal strain. So total how many strains are there? One longitudinal, two lateral strain due to Py and Pz, and one thermal strain. Biaxial state of stress. When change in temperature delta T 0. And you can also add one more for hydrostatic. Hydrostatic state of stress. So once again, when you are going for the thermal stress chapter now, I'm not going to do this all this thing now. I made a generalization now. Remember what are the things studied. Once again, when they are required, they are not going to be repeated. Only I have to prove it what a thermal stress chapter, how we got this alpha delta T, I have to prove it now. Now, but finally, what the aim of the topic here written now? Volumetric strain. How to get a volumetric strain? Summation of all this thing. Volumetric strain is given by what now? Epsilon x plus epsilon y plus epsilon z. Now if we add all this in now, if we add all this equation, what you are going to get it now? Three alpha delta t. Now from this equation 4, now, so important relation conclusion I can make it now. So when the volumetric strain is 0, change in volume should be 0. From this equation, how many condition for change in volume is 0? 2 condition. Poisson's ratio equal to half. So Poisson's, if this term should become 0, mean what? Either this term should be 0 or second term should be 0. If the change in volume should be 0, mean what the answer now? Either the first term should be 0 or second term should be 0. But when the first term is 0, when mu is equal to half. So whenever mu is equal to half, what happens now? That is perfect plastic. So once what now? Perfect plastic and change in temperature 0. So always change in volume is 0. That's why you are called a mu equal to half, mean perfect plastic you have studied. Suppose mu is less than half. If mu is less than half, so this term will not be 0. So what the other possibility? Sigma x plus sigma y plus sigma z should be 0. If delta V should be 0, change in volume should be 0. Either mu is equal to suppose if the mu is half, mean what the meaning now? Whether this term is 0 or non-zero. Always what when mu equal to half. When this term is 0, mean automatically change in volume is 0. Mean what the conclusion now? When Poisson's ratio equal to 0.5, always change in volume is 0. Means under any state of stress condition. So when you have to check this condition, if mu is less than half, still if the mu is less than half, still there is one condition is there now. What that condition now? Sum of the stress in 3 directions should be 0. That is when mu is equal to 0.5. change in volume or volumetric strain is equal to 0 under any state of stress condition. Any state of stress condition. If Poisson's ratio of a material is equal to 0.5, whatever may be the loading condition, whether load is applied in one direction or two direction or three direction or hydrostatic, always what now? Change in volume is 0. When mu is less than 0.5, change in volume is going to tell, everybody is going to tell non-zero. Even if mu is less than 0.5, still there is one possibility. What that possibility? Now sum of the stress in three directions should be 0. When mu is less than 0.5 is 0 when sum of the stresses normal stresses, default algebraic sum of normal stresses when sum of normal stress in three mutual perpendicular direction is 0. Means even in what elastic bodies also, even perfect elastic body also, change in volume may be 0. But what the possibility now? Somebody will ask now, in perfect elastic body, change in volume is 0 or non-zero means what now? May also 0. Perfect plastic means always 0. Perfect plastic means always 0. Even perfect elastic is also change in volume may be 0. But what the condition now? Sum of the stress in three directions should be 0. That is sometime once again here MSQ question is possible. For a perfect plastic, change in, for perfect plastic body, always change in volume is 0. Perfect elastic body, change in volume is non-zero. Perfect elastic body, change in volume is non-zero. Last one is what now? Perfect elastic body, change in volume may be 0 or may not be 0. Both are correct now. May be 0 or may not be 0. So which answers are correct now? A and D. A and D. But everybody is going to be what? How perfect elastic change in volume is 0. If the sum of the stress in three mutual perpendicular direction is 0. Means this is possible in case of uniaxial or biaxial or triaxial. Biaxial and triaxial. Uniaxial case is not possible. Uniaxial case you are getting only one value. So that will not become 0. So this is possible what now? Obviously what the sum of the stress are going to be 0 means what now? It is possible in case of biaxial and triaxial only. But uniaxial case is not possible. Now can you give the change in volume in all this case, 0 or non-zero now? Mu is equal to 0.5, perfect plastic. Perfect plastic means we don't need all these values. Whatever may be the value, it is going to be what now? So directly what now? 1 and 4, 0.5. But what the difference? It is about a triaxial, but it is a uniaxial. Whatever may be the state of stress, once mu is equal to 0.5, change in volume is 0. Because of perfect plastic. Because the first term is 0 means automatically second term what now? Need not be what? Maybe 0 or may not, we don't need. Once this first term is 0, automatically change in volume is 0. What about the second case now? It is a perfect elastic or elastic material. So in this case what now? It is a non-zero. Why? This term is non-zero. This term is also non-zero. If this term should become 0, what? They should be unlike in nature. But here all are going to be positive. All are positive. Plus P plus 2P plus 3P. Means sigma x, sigma y, sigma z all are going to be tensile. It is not non-zero. And what about here now? Uniaxial case. Once again it's non-zero. And what about the last case? Maybe 0 or may not be 0. We cannot directly tell it now. This term is what now? Non-zero. But this term is 0 or non-zero. Maybe 0 or may not be 0 because of what now? Only loads are given. But one is the compress is there now. Means sigma x is going to be tensile, sigma y is compressive and sigma z is going to be tensile. Only after giving the numericals, that is after calculation of sigma x, sigma y, sigma z, that is we should know length, width and thickness. In this case, may or may not be 0. Only in this case we cannot decide it now. So always under uniaxial, maybe a perfect plastic or perfect elastic. Change in volume is non. Here what now? Is a non-zero. But this 0. Perfect plastic means always 0. Perfect plastic. First and what? 1 and 4 perfect plastic. But the triaxial, but the uniaxial always 0. But perfect elastic may be 0. Perfect elastic here is non-zero because all are going to be sigma x, sigma y plus sigma z all are tensile is non-zero. Here it is also non-zero. But here one is a positive, one is a negative, one is a positive. Therefore in this case may or may not be 0. Directly we cannot tell it now. Can you write down the volumetric strain equation, hydrostatic state of stress? Hydrostatic means what you have studied now. Now what is the volumetric strain now? In this case, three sigma and what this right hand side is represent K. So K is equal to what you are getting now. K is equal to sigma by epsilon V. Means that only yesterday what is the bulk modulus valid under hydrostatic. Yesterday bulk modulus is sigma by epsilon V. But from where you got this condition hydrostatic? So this equation valid under hydrostatic only. But what about this equation? This is valid for any case. This is valid for even for hydrostatic or non-hydrostatic. But this is valid only under hydrostatic. Clearly yesterday you written a stabler form I written a bulk modulus valid under hydrostatic state of stress condition. So K is equal to sigma by epsilon V. Got it from the which condition? Hydrostatic state of stress condition. So now here volumetric strain 0 or non-zero. This will become 0 only when mu is equal to half. But if mu is non-zero, mu is less than half, it is a non-zero. So under uniaxial state of stress condition, if the change in volume should be 0, means only Poisson's ratio should be 0.5. If mu is what a less than 0.5, change in volume is non-zero. But biaxial and triaxial, even if the Poisson's ratio less than 0.5, still there is one possibility there. What that possibility? No, sum of the stress in three mutual perpendicular direction may be 0. But uniaxial, only one condition is there now. What that condition? Mu is equal to half. That is a perfect plastic. That is perfect elastic. Under uniaxial state of stress, always change in volume is non-zero. Perfect elastic. Change in volume is non-zero under uniaxial. But perfect elastic under biaxial and triaxial, change in volume may or may not be 0. Now can you write down for example is what the example for uniaxial state of stress? What the example for uniaxial state of stress? Pure axial loading. Prismatic bar under pure axial loading, axial tensile load. A prismatic bar under pure axial loading. Example for pure uniaxial state of stress here. Now what the equation you are going to get it now? How to write down the volume, area into length. Pure axial loading, P by A. So what the change in volume equation now? Probably first day this question was discussed now with the MSQ. There I have given the equation also this now. Starting about the first day, some students got the doubt. This I had taken as about a first class of your batch now. So I have taken one MSQ question based upon this now. Now it is a 0 or non-zero? It is a non-zero. So if this should be 0, only one option is what a mu is equal to half. But this volume is what a positive or negative? Change in volume positive or negative? P the positive. If a P the tensile load, it is going to be what? Positive. If the P the compressive load, then it is a negative. For a prismatic bar, pure axial loading, prismatic bar, pure axial loading. Mu is less than 0.5. this value is a positive or negative depend upon P. This value is a positive or negative depend upon P when mu is less than half. That is, volume increases under tensile load, pure axial tensile load, pure axial compressive load. And here decreases. But everybody is going to tell, sir, volume is going to be remain same. The volume will remain same only in case the volume will remain same only in case of when mu is equal to 0.5. So if the four statements already discussed now, if the four statements are given like this, which of the following statements is or are true? For a perfect plastic body, change in volume is zero under any loading condition. For a perfect elastic body, change in volume is non-zero under any loading condition. Perfect elastic body, change in volume is non-zero under pure axial loading. Perfect elastic body, change in volume may or may not be zero. What are the answers? Anybody quick now? So always better to remember which equation now? Always better remember the epsilon v equal to 1 minus 2 mu by into sigma x plus sigma y plus sigma z. If you can remember that equation, it is valid for any state of stress condition. Maybe uniaxial, maybe biaxial, maybe triaxial or hydrostatic. ACD. So these are the three statements are correct now. Or sometimes which is non-zero, which is incorrect statement out of these four now, which is the incorrect statement would only be. If the same question can be given as what now? MCQ. Same question given as a MCQ by mentioning what now? Which of the following statements are incorrect now? Which of the following statements are incorrect means B is the incorrect now. Which are true means A, C, D are true now. So overall what now? How many ways about the volumetric strain equations now? Now in this case, now these are the final equations now. Volumetric strain. Volumetric strain can be determined by three ways now. But this is valid only under hydrostatic. This is valid only under hydrostatic. But these two are valid under any state of stress condition. These two are valid under any state of stress condition. Any state of, suppose if the change in temperature is there, what change you have to make it? And if change in temperature is there, you should also add the 3 times the thermal strain. 3 times the thermal strain if change in volume is also there. Change in, sorry, not change in temperature is also there. You have to add the 3 alpha delta T. So this is only under hydrostatic. These two are under any state of stress condition. But equation 1 is better or 2 is better now? Equation 1 is better or 2 is better now? This is under hydrostatic. These two are valid under what now? These two are valid under any state of stress condition. This is under any state of stress, but this is any condition. This condition is also valid even when no load is there. But this is valid what now? Only when loads are there. So which is the better equation now? Equation 1 is the better. That is valid for what now? Equation 1 is better now. That is valid under any state of stress condition. Sorry. Under, slightly correction is required. This is valid what now? Under any state of stress condition as well as what now? Even in the absence of the loading condition. Even in presence of change in temperature also I can use it now. But this is valid only when loads are there. In the absence of load, we cannot use this now. Suppose if only change in directly, we cannot use it now. There you have to go for the 3 alpha delta T. But this is only hydrostatic. Now in this case, to determine the change in volume, which equation should be used now? First or second or third? Only first now. Second is not valid now. Second is not valid. Here stress are 0. There is no stress. So we can use this first equation. Here second equation not valid, third is not valid. This is only what I mentioned now. The equation valid even in presence of load, even in the absence of the load. That is, this equation valid when the loads are acting, as well as what even change in temperature is there. But if this equation also, you have to make a generalized equation. If this equation also should be made a generalized equation, then you have to add the 3 alpha delta T. So in this case, only equation 1 should be used, because equation 2 is not valid. Because sigma x and sigma y, sigma z are 0, because there is no load. What the other equation you can write down now? Now this is a generalized one. But this is valid when only loads are there. But this is valid what now? When the load is there and even if change in temperature. So for this question, only equation 1 should be used. Otherwise, equation 1 and equation 1 and equation 4 should be used. 4 should be used. So this is valid what now? Any loading condition or even in the absence of the load. Yesterday already studied. But this is valid only when loads are acting. This is valid only when the loads are acting. Then only stress are there. This is only under hydrostatic, but this is even if the loads are 0 or even if change in temperature there, both are there. Both the case is valid now. So 1 and 4 are generalized now. 1 and 4 are generalized now. 1 and 4 are generalized. That's why for this case what now? Only equation 1 and equation 4 should be used, but 2 cannot be used now. Now we'll take a break now. I know what 10 minutes is there now, but these are all interrelated. Once again, what now? If I am going to give a break now. So this we cannot continue, we cannot discuss now. When a topic is going on, what now? We have to complete that entire topic now. But after I am giving a break now, once again, I cannot write down all this thing now. But if I go for a movie now, Nobody will ask what now. If 4 hours movie is there now, 3.5 hour movie is there now. Nobody will question the director now. Why you are given the break? If 4 hours movie, you have to give a break exactly 2 hours. Interval should be there. Nobody will question him now. Even the 4 hours of movie now. Even if the 2.5 hours is there now. 3 hours is there till break interval now. Nobody will question now. Because they are focused there now. But here, sir, please give us break, sir. At that time, even if for the 3 hours movie, if the director is what made a producer what he has made a movie for 4 hours, nobody will question him now. The movie is 3 hours only should be there. Why you are extended for 1 hour more? Nobody will question him now. But when coming to the classes, sir, you are exceeding the timing, sir. Give a break, sir. These are all time pass. These lectures are time pass. The movies are what now? Lifetime enjoyment will be there now. But this will give about a lifetime pain they will give it now. I know I have to give a break now, my dear friend. You need not remind me. I need about a more break now. 4 hours, 15 minutes, I am standing now. I don't know whether you came to the class with having some breakfast or something now. But I came to the class what now? Without breakfast now. But I am standing about a 4 or 15 minutes, I am without sitting now. I should tell what now? I need a break, my dear friends now. But you are reminding me now. Sir, give a break, sir. When a topic is going on, how to I what now? Give a break now. In between. If I am going to start some new topic, then you can ask a break in between now. So when you are studying what now, you have to complete 100%, you have to complete it now. I am telling what only this type of category are going to be there now. So many times I mentioned my lectures are going to give a short-term pain, but they will give a lifetime enjoyment. You get what each and every information, you need not get it now. No, very well not. This statement what never what now. This I have not written any of the batch now. First time I have written all this thing now. Because the exam is what MSQ is there now. Recently I completed 3 batches, but there I are not given now. Yesterday I have given the difference between what now? Hydrostatic as well as what now? Hydrostatic state of stress as well as what now? When sigma x equal to sigma y. You are all asking a doubt regarding that now. I prepared a table. First time I prepared a table. That's why I taken an image for me also. When you want something, you have to sacrifice something now. But if you go for movies and functions, what now? They will give a short-term enjoyment, but they will give a lifetime pain now. They will not give lifetime enjoyment. But these classes are going to be give the what now? Short-term pain, but lifetime enjoyment will be there now. When you are going to solve the question, then you will realize what is the importance now. Please don't ask what now in between what now. Please don't send the messages, sir, give a break. If I am starting one new topic, then you can send a what now request, sir, please give a break now. So you have to understood why sir is what now. Whether I am wasting my time or what, I am not wasting your time. I am wasting my personal time now. So now we'll take a break. Now it is 12:15. So we'll go into 25 minutes break, 25 minutes break, because somebody can have the lunch also you can have, because the 3 o'clock will be there. If your lunch is ready, you can have finish off your within 25 minutes. Now as per my watch it's 12:15. We'll start at 12:40. 25 minutes break will be there now. So any questions now? If you have any queries, you can ask. Otherwise, we'll take a break now. Mr. Deepak Kumar, what you are asking now? Sir, what are example given, sir, of movie excellent? I don't know what you are asking now. Distortion means what? The shape of the block is changes, my dear friend. Deformation, what you have studied now. Distortion means the what the shape of the block is going to be changed. In deformation means what happens now? Shape will not change now. Only dimension will change. Distortion means what the cross-sectional dimensions are remain same, but shape is going to be changes. Deformation means shape will not change. Only dimension will change. When a bar is going to be pulled, first day you have studied now, when a bar is pulled, length will increase, cross-sectional dimension will decrease. Cylindrical bar will remain as a cylindrical bar only. Length will increase and cross-sectional dimension will decrease. I shown the word deformation and distortion. Distortion means the shape of the block is going to be, shape of the member is going to be changes. Deformation means shape will remain same, but only dimension will change. A prismatic bar is pulled, length will increase, cross-sectional dimension will decrease. Cylindrical bar will remain as a cylindrical bar. I hope your doubt is cleared. Check it what I have already given the answer, my dear friend. -5. Once again, you try it now. Sinha, you can try it now. I have already given the morning. I have given now. I have given hint and everything I have given, and you are asking what now? Please solve it. I have given the answer. I have given the explanation also given. You can try it. If you are not getting, tomorrow we'll try it now. Okay. So 1 or 2 queries are there. I responded. So we'll start at 12:40. Thank you one and all. Thank you.